Hello and welcome. In this video, I will talk about interval and set notation. I have designed this lesson for my grade 12 students who are taking the MHF 4U course, which is the Advanced Functions course. But I must add that this lesson can very easily be understood and used by students from grade 9 to grade 12 or maybe even younger, who knows. So let's get started. So far, we have described the domain and the range of a function in set notation. And this is what it looks like. Domain, semicolon, braces, x, er, which is read x belongs to the set of real numbers. And you try to write to write a fancy r in here or draw a fancy r. And then such that x bigger than or equal to -5, for example, and then close the braces. Or for the range, similar to domain, we've said range, regular r, semicolon, braces. This time we say y, er. There goes your fancy r for the set of real numbers. So y belongs to the set of real numbers such that y is less than, for example, 0. The set notation is quite descriptive, but in the meantime, it can be a lot of writing in order to describe a set of numbers. And that's why we are introducing you to interval notation. And I promise you that once you get into interval notation, you will prefer that method over the set notation. So I brought some examples here, all examples of set notations, and we are going to convert them into interval notations. And I will explain the details of set notations as I go over each and every example. So the first one states that x is any real number such as x is bigger than -3. And here goes the number line. First we want to graph this set of numbers on the number line and then describe in interval notation. So listen carefully to all of the examples as they are all similar yet different and will bring something new to the understanding of interval notation. So we always start from the numbers given. So what we have in here is x bigger than -3. First, we locate -3. And we draw a circle around -3. Whenever you have bigger than, what you want to do is leave the circle empty. That's because -3 is not included in the set of numbers. The x values have to be greater than -3 but not equal to, and that's why this is empty circle. And then the rest of the numbers that are bigger than -3 are to the right of -3. So we'll describe them by this line and the arrow at the end. When it comes to interval notation now, we say that x, I'm going to make this, right, belongs, and you always start with the numbers from left to right. So on the left you have -3, so you'll write -3, comma, and on the right side we continue to infinity, so we write to infinity. Now because -3 is not included in the set, then we are going to use round brackets around it. And infinity, or negative infinity for that matter, always is surrounded by a round bracket as well. And this is the interval notation presentation of this set of numbers. So moving on to the next example, we have x less than or equal to 4. So first, locate number 4, draw a circle. The next thing you want to check and see is it equal to 4 as well? It seems that it is. So fill the circle. The set of numbers here described is less than 4. So all the numbers less than 4 will be to the left side of it. Therefore, you draw the line to the left. And when it comes to interval notation now, we're going to say that we have x belongs to, you start with the left end of this line or set of numbers, which is infinity, negative infinity, and you end it with the right end of the number line here, or the set described on the number line, which is 4. Now around negative infinity or positive infinity, we always have round brackets. Because number 4 this time is included on the set of numbers, we use the square brackets. So the square brackets indicate that the number is included in the set. And the round brackets, the actual number is not included in the set. The next example, we have x is bigger than negative 2, so you can look at it in two different ways. X bigger than negative 2 and x less than 3. So these two conditions must be satisfied simultaneously. So what we are going to do is first describe x bigger than negative 2. So we'll go at negative 2. And all the numbers bigger than negative 2 will be to the right side of it. And then we move on to x less than 3. So we locate 3. Remember, number 3 is not included, so empty circle. And all the numbers that are less than 3 will be to the left side of 3. So this way. Now, because the two conditions must be satisfied simultaneously, we are going to say that the set of numbers described in here will be between negative 2 and 3, where both pink and green, right, are overlapping each other. So this time we're going to say that x belongs to, we start with negative 2, that's the left end, comma, positive 3. Because the ends are not included, so negative 2 and 3 are not included in the set, we're going to use round brackets. Now, with this example, you probably understand the reason why we need to write x belongs to. If we wrote simply negative 2, 3, which sometimes people do actually, you can misinterpret it as a point on the Cartesian plane. But when it doesn't represent the point on Cartesian plane, which is the case in our case, then you must write x belongs to. So the next example, and you are more than welcome to stop the video and try it on your own, because I think you can, is x bigger than negative 4 and less than or equal to 0. So negative 4 is right here. Negative 4 is included, and all the numbers bigger than negative 4 will be to the right end of it. And also the numbers must be less than or equal to 0, so here goes 0. 0 is included, and all the numbers less than 0 will be to the left side of 0. So the set of numbers described in here is the numbers between negative 4 and 0. So we're going to say that x belongs to the set of number between negative 4 and 0. Remember to read from left to right, just like you read a book. And because both ends are included in the set, we have to use square brackets, both ends. In the next example, we have negative 3 and 1. So x is between negative 3 and 1. So we're going to start with negative 3. Draw a circle. Bigger than negative 3 means to the right of negative 3. Then we go to negative 1. Oh, positive 1. Fill the circle because it's also equal to positive 1. And all the numbers less than positive 1 will be to the left side of it. So the numbers described in this set are between negative 3 and 1. So we'll write that down. X belongs to negative 3, comma 1. And now we have to take another look at the numbers. Negative 3 is not included in the set. So that means round brackets around it. And positive 1 is included in the set, so square brackets around it. So the last example, again, you're more than welcome to try on your own, is between negative 1 and 6. Now, negative 1 is included in the set, so I will write a fill circle in here. And positive 6 is not included in the set, so we are going to write or draw an empty circle here. And we'll say that the numbers will be between negative 1 and 6. Negative 1 included, so square brackets. 6 not included, so round brackets. Okay, so in the next examples,